In this video, I'll be helping you with a math topic called the power of a quotient rule of exponents. And we can see here that this rule says that when we have a quotient, like a over b, raised to a power, that power applies to both the numerator and the denominator. And we have a couple of examples here to use this rule. The first being 4 over z to the 11th raised to the third power. This power applies to both the numerator, making it 4 to the third, and the denominator, so z to the 11th to the third. In the denominator, we can simplify to z 11 times 3, the power would be 33. And in the numerator, 4 times 4 times 4, we can simplify as 64 as our simplified expression. For b, we have p over q3 raised to the 6th, applying the power. In the numerator, we would have p to the 6th, and in the denominator, q to the 3rd to the 6th, which we could then simplify to be p to the 6th over q to the 3 times 6, or 18. For c, negative 1 over t squared to the 27th, the negative 1 would be raised to the 27th, and the t squared would be raised to the 27th. In the numerator, negative 1 raised to an odd exponent is going to give us negative 1, and in the denominator, the power inside times the power outside is t to the 54. For d, at first glance, we do not have a quotient to use the quotient rule. However, we are eliminating those negative exponents to make them positive. So I could start by rewriting this, moving the k to the negative 2 to the denominator as j to the 3rd over k squared raised to the 4th. Here we can apply the 4th power to both the numerator and the denominator. Simplifying the numerator gives us j to the 3 times 4 is 12, and the denominator of k to the 2 times 4 is 8. And then for our last example, e, we have two variables inside the parentheses, both raised to negative exponents. So I can remove those negative exponents from the beginning by moving both to the denominator, and they are still raised to the 3rd power. And now the numerator needs to be raised to the 3rd power, as well as each one of the values in the denominator. So m squared is raised to the 3rd power, and n squared is also raised to the 3rd power. Simplifying 1 to the 3rd is just 1. Multiplying the exponents when I have one inside and one outside, the parentheses gives me an m to the 6 times an n also to the 6.